Yeah.
All right, here we go. Guys, we're going to continue on this idea of parallelograms. You know some things about parallelograms. And we're going to take a few more theorems and throw at this. It's actually a pretty simple section. Right?
Easier than the last one?
About the same. I think the last one was pretty easy. Okay. Guys, proving quadrilaterals are what?
Parallelogram.
Give me some characteristics of parallelograms again, please. What's one, Ty?
Parallel sides.
Sides?
Parallel.
How many pairs? Two pairs, parallel sides, all right? Okay. What's true about opposite angles?
They're the same.
They're the same. What do diagonals do to each other?
Bisect.
They bisect each other. They cross in the midpoints of each segment. Okay? So we know some.
Bisect?
What's that?
That we call bisect.
Bisect. Cut it in half. Two segments cut in half. Yep. So our question is, how do we prove that a quadrilateral is a parallelogram? We're going to take what we know about a parallelogram. We're going to say, well, since the opposite sides are parallel, it must be a parallelogram. We're going to have ideas that make this true. So, guys, our goals then to answer that question, looking at identifying and doing what? Verifying a parallelogram, and then we're going to show that a quadrilateral is a in the. All right, so we know what a parallelogram is. So let's talk about the diagonals of a parallelogram. In a parallelogram, what are the diagonals? Okay, so just opposite, it's just a segment that connects non-consecutive vertices, right? So here's my parallelogram. Okay. Here's one diagonal, and here's the other, right? So those are the diagonals in that, and then a parallelogram. I've got this kind of screwed up. This should say, I've got this screwed up. This should say parallelogram up here, so write that down. And this should say diagonal. And this drawing should actually be down here. That's okay. Leave it up. Leave it the way you have it. It's okay. So I'm going to draw a parallelogram up there anyway. Here's my parallelogram again. Okay, what's true about opposite sides in terms of their lengths? Well, there's the email, kids. We're getting out 2 hours early.
Yay!
Really? Today?
From Mr. Jim Caton. Early dismiss. We will be dismissing 2 hours early today.
Wait, so that's what?
We will run a normal schedule at this point, dismissing at 1:08.
Yes!
Wait, is it really going to be that? Wait, so we won't have to
Huh?
We won't have to
That's so great. Mr. Well, I like Mr.
Okay. Guys, let's focus.
Let's learn.
Let's focus. I want to get through this. Come on now. Hey, come on. Come on. Come on. Are we ready?
Sorry, I got
That's okay.
excited.
I'm happy for it. That's awesome. But I want to finish this, okay? Okay. All right. So, parallelogram. What's true about opposite sides?
They're equal.
They're equal and what else?
Parallel.
And parallel. So these symbols right here are important. All right. So, a couple theorems we need to know to be productive today. The first one is called the parallelogram opposite sides. What's the word? Okay, listen to what I say here. Let's just talk about converses again, turning stuff around. Listen to what I say. If it rains, we get out 2 hours early. Then we get out 2 hours early. What's the converse of that?
If it doesn't rain, we don't get out.
Then it rains, right? It's switching the hypothesis and the conclusion around, right?
So if it rains, we get out.
All right, listen to this. Listen to this. Let's make it even easier. If A, then B. What's the converse? If B, then A. So what they're saying here is this, kids. In the last section, they always said you have a parallelogram. These are the characteristics that must be true. The converse is now saying these are the characteristics you have about a shape. Therefore, it must be a parallelogram. So what we call up here, guys, is the parallelogram opposite sides converse. And it's going to be abbreviated POSC. Okay, it says if both pairs of what? Opposite sides of a quadrilateral are what? Meaning one side across from the other. Those sides are equal in length. And so what I'm saying is this. Then the quadrilateral is what? Okay, so here's what this is saying. This is really saying if you have this. If you have some quadrilateral, it looks like this. And I say, if this is A, and this is A, and this is B, then this is B. What's true about opposite side lengths? How about the top and bottom? Are they same or different?
Same.
They're the same length. How about the left side and the right side?
Same.
Same length. If the opposite sides of a quadrilateral, meaning four-sided figure, are the same, then this is what type of shape? Is it okay if I abbreviate down? It's a parallelogram. Okay. Next one, parallelogram, opposite angles converse. It says if you have pairs of opposite angles of a quadrilateral, you got a four-sided figure, opposite angles are what? Equal, then it must be a what? So they're saying if you have a situation like this, here's your four-sided figure. If the angles here are A and A, are they across from each other? Are the angles across from each other here? If that's true, then your figure must be a what? They're saying then parallelogram. Okay? Pretty much. Hey, what do you want to call this?
Poke.
Poke? I'm going to poke you.
That's the funny.
Facebook poke you.
It used to be poke, now it's wave.
Is it the wave?
'Cause I think poke was too like weird.
Oppressive.
You know?
Bro.
Inappropriate.
I'm gonna
Yeah,
poke
maybe.
Appropriate.
I feel like waiting for something.
Because poking is like you're either flirting or like I don't know.
Okay, who added? Did everyone like actually poke someone? Be like, yo, what up? Poke?
It's just weird.
Okay. Label your vertices as follows in order. A, B, C, and D. It says in quadrilateral, A, B, C, D. What's true? AB is equal to what? So if I put a tick mark at AB, I better put a tick mark where?
TV. Oh, yep.
And what else?
Oh, I did
Well,
that
that's
wrong.
weird.
Oh wait, this is.
CD is equal to what? Now I know that this is deceiving because it looked like a parallelogram.
Yes, but it's not.
Oh.
What is it?
Question becomes,
It can't be.
is this a parallelogram based on the way they describe this stuff up here?
No.
Why not?
Because it's not. Opposite sides aren't equal.
Opposite sides are not equal. AB is equal to what according to the draw or to the wording up here?
See.
Okay? And this is are opposite sides congruent?
Not to our knowledge.
No, not to our knowledge, not with what's given up here. So what I would say is this. I would say, since opposite sides are not congruent, we can't, since opposite sides are not, what's the next word?
Congruent.
Since opposite sides are not congruent, then ABCD is not what?
Not a p-gram.
Not a p-gram. It's not a parallelogram. Oh! Yeah, I had that right. So again, one of the properties of, in order to be a parallelogram, opposite sides have to be equal, don't they? Is that happening here? The answer is. So what I want you guys to do is this. Take what you know about parallelograms and find some side lengths. I'm going to set this up as a T-chart. Take a minute and see if you can figure this out. You and your table mate, take a minute and figure those out. Figure out what x is, figure out what y is. And tell me how you know.
How does that work?
Yeah.
Don't worry, we can find both. Email.
If there's no x, you just keep the x and make the thing we get.
Well, here's the deal.
So I'll do it.
How would you set up to find x if this was a parallelogram? It says for what values of x and y is a quadrilateral A parallelogram? How would you set this up for x? What would you do, Adam?
I would do 24 minus x equals x plus 6.
Okay, how many agree that I can look at the left side and the right side, they both have an x in there, and I can set those equal, right? Would it help to set both of these equal right off the bat? It'd be kind of tough, wouldn't it? Because how many variables are you dealing with? Okay. But if I set the left side and the right side equal, can we solve for x?
Yeah.
Okay, how do you want to proceed with this?
Minus 6.
Minus 6 from both sides.
Why did I not write it in the table?
So I have 18 minus x equals x.
Plus x.
So add an x, so I have 18 equals 2x.
X is fine.
So from this, x would be 9. All right. Now, does knowing x help us try to find y now? Yeah, y would equal this 2x plus 3, wouldn't it? But based on what we just did, kids, what's your x value? So y would equal 2 times plus, which makes my y value what here? Okay. So 21 there. 9 and 21. Okay? So this is that idea again. If this is going to be a parallelogram, what has to be true about the lengths of opposite sides? It'd have to be
You
equal.
only have to find one of the sides, really.
Really, once you find one, then you use the one to find the other. Okay? All right, so let's look at a couple more theorems here that are pretty easy. We talked about this already. We said, guys, sides opposite of each other have to be congruent. That you just have to have that in order to verify it's a parallelogram. Okay, so let's look at some other converses. Or other things. This is opposite sides parallel and what? Okay, listen to this one right here. It says, and this is the biggie right here. You might want to underline this. This says if how many pairs of sides? If one pair of opposite sides of a quadrilateral is or are if one pair of sides of a quadrilateral are congruent and what? Then so what this is saying is this. It's saying if this. Oh, I don't want that. That's big there. Here's what I want. If this. Here's a four-sided figure. It's saying if this is parallel to this up top and you know this and this are equal, that's true. If those two sides that are across from each other, first of all, if they're parallel, and secondly, if they're the same distance, then the shape you have is parallelogram. We don't need to know anything about these other two sides anymore. As long as I have, hey, pair of sides, they're parallel, yes? They congruent? Yes, then what is this?
The parallelogram.
It's a parallelogram. Okay?
Well, except when you have to explain that.
Okay, and we're going to look at one where we have to explain this. Okay? So then the other one says it's the parallelogram, diagonals, converse. It says if the diagonals of a quadrilateral do what? Then the quadrilateral is what? This is what this is saying. If this is true right here, here's a four-sided figure. You draw your diagonals in there. Okay? This is simply saying, okay, well, if your diagonals bisect each other, in other words, this distance and this distance are the same, and this and this are the If you see something like that where you have a four-sided figure and you look at the diagonals and they say, oh, the diagonals bisect each other, meaning that each segment for a diagonal is the same length at the point where they intersect, well, then this must be what? Okay, so let's talk. Let's use these ideas. In example 3, it says, use the photo in example 3 to explain how you know that S is congruent to you. Let me get the vertices drawn up there for you kids. Oh, where did the book go? There we go. Yes. So,
Wait, so since it's on hours, we get out like 2 hours early, do something to get 2 hours.
that'll affect your time. Again, we have hours built in, but it's 2 hours that we didn't get in today. So, yes.
Oh, it's not bad tomorrow.
You guys just need to quit missing school. That's what it comes down
Yeah,
to.
could you imagine if like it's perfect for you to make up 2 hours just to go to school? That would suck. Oh my gosh.
Or just have like 2 classes.
Yeah, just have the 2 period things.
No, we'd probably just have like an assembly the whole day or something.
Alright, so.
Okay, I'm going to label these S
2 hours.
Just throw your phone
and
for 2
T,
hours.
and this is U, and this is V. Okay? And here's the deal. They're going to explain how you know that angle S is congruent to what, kids? Angle U. So here's what I'm going to tell you to do here. I got to make sure I have the right. All right. Here's what they're going to give you for information. This is the information given. That's all they give you right there, kids. So let's chat about this. First of all,
Wait,
what information is giving in that four-sided figure?
Opposites are well, ST is parallel to VU, and they're the same way.
Okay, so ST is parallel to VU, and ST is congruent to VU. Okay? So, what can I say first of all?
That
It says up here.
You can just say
the theorem itself, because
Is it the one on the left or the one on the right?
the opposite.
So the first thing I can say is this. The first thing I can say is this. Where did my pen?
explain how S.
There
That's
it
super
is.
easy actually. So
Okay, first of all, do you guys agree that S is opposite of U?
yeah.
So if I could show that this shape was a parallelogram, then we could say by opposite angles theorem, they're congruent, right? But first thing, we don't even know if this is a parallelogram. Or do we? Okay? What do you guys think? What could I use to prove this is a parallelogram? Is this like the one on the left or the one on the right up here in our theorems?
Opposite side.
Opposite side?
Parallel. And congruent.
Okay, is that what it's called? I didn't give an abbreviation for that, did I? Should we call it?
OSPC.
Should we call it the opposite sides parallel and congruent theorem?
Yes.
OSPCT? Sounds like a song I know. RASPCT? OSPCT?
What?
Ow! All right. So the first thing you can say, I'm gonna say this by opposite sides parallel and what? OSPCT. I can say this quadrilateral. I'm going to abbreviate quad. S, T, U, and V must be what kind of a shape?
Parallelogram.
Okay, so we've confirmed first of all that this is what?
Parallel.
Parallelogram. Now, since it is a parallelogram, we can say by the parallelogram opposite angles theorem, or POAT, by parallelograms opposite angles theorem, S must be equal to what? Does that make sense?
Yes.
Now, by parallelogram opposite angles theorem, because we know we have a parallelogram now, right? We've established that we do have a parallelogram, right?
Yeah.
By parallelogram opposite angles theorem, we can say angle S must be congruent to angle U. Okay? So what we're doing is we're first of all saying, okay, these are the conditions I have. I have to say, by this, we know it's what first. And then once you know it's a parallelogram, all your properties apply. Opposite sides and opposite angles are going to be the same. All right? Okay, next example. Let's see how good you are.
You know how there's like trigonometries? They're like a parallelogram on because that'd be nice. This stuff's pretty easy.
Pretty cool. We call it geometry, geo.
Oh, darn it.
Carson, wait, and like if you do a college class, you're gonna like prove stuff. Do you read it like that, or they make you write it out?
They'd make you write it out. I've got to go back. I wish I could. I don't know where I've placed those tests at. I'd like to show you some of the college finals I had to take, you and I, for my math finals. The class was called Geometric Transformations. You know, one problem might turn into be like 17 pages of writing just to prove something. Oh, it was a nightmare. So, oh yeah, I did really well at it because I was part of the nerd herd. But yeah, I like that stuff. Okay, hey, I want to see what you guys come up with here. So it says,
Did they grade you on like punctuation and stuff too?
it was basically like writing out math instead of just doing problems. You wrote and
Like
wrote.
if you like misspelled something.
They might. I don't remember. Honestly, don't. I have to be honest with you. Everybody says college is the best time of your life. It was like the worst time of my life. I did not enjoy college.
Well, it's not like you went to like easy college, like some.
Yeah.
Easy.
Yeah, easy major. That's all.
Yeah, you went to pretty hard major.
Yeah,
You kind of
it's
challenged
teaching
me.
and
Like
then
Penn
math.
Seth had the right book. His book.
Yeah, he has like a,
Nuts.
Like, no one's ever quite read that except for the professor that created it.
Yeah. And that's kind of what I say. I know you guys aren't going to use this a ton, but I want you to be able to challenge yourselves and be mentally motivated to meet challenges. So what I want you guys to do here quick, see if you can find the diagonal lengths of the parallelogram. It says, for what value of x is a quadrilateral CDEF a parallelogram? Okay. What has to be true about this and this if this is going to be a parallelogram? They would have to equal each other. So go ahead and solve that quick, or tell me what to write. Okay? All right, far too much talking on, so let's get focused back up here for me, please. All right. Yeah, if that's going to be a parallelogram, what has to be true about those distances from C to N and N to E? Okay, so help me.
11.
So add 11.
Yeah.
I've got 4x equals 2x plus.
And minus 2x.
So what's my x value, kids?
2x equals. Oh, okay, 14.
X would have to be 14. Very good. Whoa! Take a bite out of crime. There we go. X equals 14. Okay, again, guys, is this really any different than what we did in the last section? No. It's saying what would this have to be in order to make this a parallelogram? You're still applying kind of the same things here. All right, last example. Anybody need more time there? I believe the last one's a proof, isn't it? No?
Oh,
Wait, it's not.
Oh, I like this one.
Oh my gosh.
Okay.
Yeah. It is.
Okay, show that ABCD is a what?
Stop.
parallelogram.
There are so many ways. There are so many ways I could do this. Okay. Okay, let's talk.
All their sides are the same.
Okay, so how do you know the sides are the same?
They take the same square.
Okay, I'm going to blow this up one.
The distance is the same.
Yeah, the distances are the same. So talk to me. Which side are you talking for distances the
I
same?
was looking at the shorter one.
So you're looking at, if I understand you correctly, are you looking at A, B, and C, D for lengths? Okay, let's see what Ty's got to say here. I want to look at this real quickly. I think you're onto something here. Okay. Okay, so you're looking at this distance and this one, right? All right, help me out, kids. If I look at just those two sides, what characteristics must be true about those two sides to show that maybe this is a parallelogram? They're parallel, number one.
And they're the same length.
So if I can show that they're parallel and congruent, if I can show that opposite sides are parallel and congruent, then we must have what?
And then using a less PC.
So what I'm going to do here is this. I'm going to say the following. We're going to show opposite sides parallel and congruent theorem. We're going to show this, okay? So let's start by doing, let's start by showing, to show parallel, we'd have to show the slopes are the same, right? So Ty has chosen to look at the sides A to B, and what else? C to D here, right? A to B, right here, and C to D. Okay, let's talk about the slopes of them first.
Up 1 over 1, 1.
Okay, the slope from A to B would be, isn't it really up 2 and over 2?
Yeah.
Slope from A to B equals 2 over 2, which is 1, right? Slope from C to D, rise 2 and what? Rise 2 and run 2, which would be? Okay, so I've established that the slopes are the same, so the lines right here must be parallel. Okay, so on the opposite sides we have, okay, we've established opposite sides because A and B are opposite of each other. We've shown that they're parallel. Now if I could just show that they're what? Well, congruent, right?
Same.
So my distance is going to equal the following. You're going to take your distances that you use from slope. It's going to be the square root of 2 squared plus 2 squared. I have no idea what that is. Somebody run that. What's 2 squared plus 2 squared? 4 and 4 would be 8. So isn't this just going to be the square root of 8 here, kids? The distance there is going to be whatever the square root of 8 is, right? Okay. Well, what did I use for rise and run to get from the 2 points here?
Same.
Yeah, the distance right here would equal square root of 2 squared plus 2 squared, which is equal to the square root of 8. Those are both going to be, gosh, I think, try somebody, is it like 2.828? Somebody run that. Square root of 8, is it 2.828?
2.8284.
Okay, so kids, how do you know this is a parallelogram? How do you know they're a parallelogram?
Same distance and they're parallel.
Opposite sides are parallel and congruent. So I'm going to say this, since AB is congruent, and what else? Opposite is congruent and parallel to what? To which side, kids? Okay, I'm going to say quadrilateral. Quadrilateral, I'll abbreviate it quad. Quadrilateral ABCD must be what? Must be what? All right, I'm going to send out the new online here quickly, so have your Chromebooks out. ready to go.
I gave it to him. Some people won't get to do that.